In this video, we're going to talk about intercepts and turning points of polynomial functions. So an X-intercept is defined as when a curve intersects the x-axis, and here we have two of them, one right here and one right here. Y-intercepts are when a curve intersects the y-axis, which we have one right here. And turning points are when a curve changes from increasing to decreasing or vice versa. So here's an example of when a function turns from increasing to decreasing. That yellow dot is a turning point, or decreasing to increasing. This yellow dot is also a turning point. And I just want to point out that we can really easily find x and y intercepts by setting f of x equal to 0 and solving for x. That gives us the x-intercepts. And then setting x equal to 0 and solving for f of 0 gives us the y-intercepts, or one y-intercept in this case. I also wanted to note that the x-intercepts are also called zeros of a polynomial function because we're setting the function equal to 0 to find them. Okay, let's do a couple of examples of finding zeros and y-intercepts of functions. Okay, so we're going to start out really easy with a linear polynomial function, 4x plus 6, and we want to find the intercepts, both x and y, of this function. So first what we're going to do is we're going to set x equal to 0 to get our y-intercept. So f of 0 is going to be 4 times 0 plus 6, or 6. So that's our y-intercept. And to find our x-intercept, we set f of x equal to 0 and solve from there. So that's going to give us 0 equals 4x plus 6. And then we want to solve for x. So we'll move 6 over and then divide by 4. That gives us negative 6 divided by 4, or negative 3 halves. That is our x-intercept, or our 0 of this 4x plus 6 function. Okay, let's move on to something maybe a little bit trickier. Okay, so now we have this function x squared plus 5x plus 6 that we want to find the intercepts of. To find the y-intercept, we can do the same thing. Just set x equal to 0 and solve. So that gives us f of 0 equals 0 squared plus 5 times 0. That's by plugging in 0 into here and 0 into this x here. We still have this plus 6, but then this is going to be 0 plus 0 plus 6. So that gives us 6 as our y-intercept here. And then to find our x-intercept, or our zeros, we want to set f of x equal to 0 again, just like we did on the previous example. This is going to be a little bit trickier because we have to factor this quadratic polynomial. We call it quadratic because we have a 2 as our degree of the polynomial. A second degree polynomial is just called a quadratic polynomial. We need to factor this to get our zeros. So how we're going to factor this, we're going to set it up like this. We have two terms. We know that each of these factors has to have an x because x times x equals x squared. And then we also know that some combination of 1, 2, 3, and 6 is going to be used to get 1 and 6 here because those are the factors of 6. These are the only combinations we can use to get 6 are 1, 2, 3, and 6. 1 times 6 is 6, 2 times 3 is 6. But the only one that adds up to 5 is 2 and 3. So that's pretty easy. We use 2 and 3. And so now we have our factored form. And again, we're setting this equal to 0. So that's going to be 0 there. But now, if you multiply two numbers together and you get 0, one of them has to be 0. Otherwise, this product wouldn't be 0 over here. So either x plus 2 equals 0, or x plus 3 equals 0. This is going to be x equals negative 2, x equals negative 3. And this is how we get multiple zeros, like we did in our example before, or multiple x-intercepts, is by this sort of factoring and then taking all of these possible values for x to be 0. Notice that if x equals negative 2, this side is going to be 0, and thus the product is going to be 0. If x equals negative 3, this factor here is going to be 0, and thus the whole thing will be 0. Because if you multiply any number by 0, you get 0 back. So simply put, these are our x-intercepts, or zeros, of this function up here. Okay, so we're going to do one more example of a function that's actually already in factored form. So here we have x plus 2 times negative x minus 3 times 4. Okay, so let's go ahead and find the y-intercept again by setting x equal to 0 This time we're going to have a little bit of calculations to do. So if we set x equal to 0, we have 0 plus 2 times 0 minus 3 times 4. But that's going to give us 2 times negative 3 times 4, which gives us negative 6 times 4, which is negative 24. That's going to be our y-intercept in this case. And then to find our x-intercept, or our zeros, we set f of x equal to 0, and we solve it from there. But notice this is already in factored form. So when we look for the zeros of this function, all we have to do is set each of these terms equal to 0 and figure out what x should equal for each of them. So this term is equal to 0, then x plus 2 equals 0, then x equals negative 2. So that's 1 0 of this function. If negative x minus 3 is equal to 0, notice that would cancel out the whole thing, because if you multiply any number by 0, you get 0. If this is equal to 0, then x is going to be negative 3. And if you set 4 equal to 0, well, it doesn't matter what x is. 4 is never going to be 0. So these are our 2 zeros of this function f of x. Okay, that's good enough for now.